Good morning, science-minded learners. For today, we will be discussing about polarity of molecules. Before anything else, let us first have a review on the things that we need to recall to help us understand our lesson for today. So during your grade 8, you have learned about the octet rule. So octet rule, it dictates that atoms are most stable when their valence shells are filled with 8 electrons. So what do you mean by valence shell? So valence shells, these are the last shell or the outer shell of an atom or of an element when we write it or illustrate it in its nuclear model. So for example, let us have here neon. So si neon, meron siyang atomic number na 10. So I have here my periodic table of elements. So meron siyang atomic number na 10. So this means yung number of protons and number of electrons niya ay 10 as well. So according to the octet rule, on the first shell, so these are the shells, okay? This ring, these are what we call the shells. So according to the octet rule, kinakailangan sa first shell ay meron lamang 2 electrons. And on the next shell until the 7th shell, kinakailangan na meron siyang 8 electrons para makaproceed to another shell. So here, si neon on its first shell, meron siyang 2 electrons, right? At na-fulfill niya yung octet rule. 1, 2. Next naman, on the second shell, kinakailangan na meron siyang 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So, na-fulfill ba ni neon ang octet rule? Yes. So, this is the valence shell. These electrons naman is what we call the valence electrons. So valence electrons, these are the electrons present in the valence shell, okay? So kung i-count natin yung electrons present is in this nuclear model, this is equal to the number of atomic number ng neon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that is the how elements fulfill the octet rule. So this means that neon is a stable element. But an exemption to an octet of electrons is in the case of the first noble gas, which is helium. So we have here helium. So bakit exemption ng octet rule yung helium? Because meron lamang siyang 2 valence electrons. Kasi meron siyang atomic number na 2. So when we write it or illustrate it in nuclear model, ganito lang siya. So, meron lang siyang 1 shell, and then on that shell, meron siyang 2 valence electrons. So, ito na yung valence shell niya. Since ito lang naman yung shell ni neon, and then ito naman, yung dalawang electrons are what we call the valence electrons. Okay. So, that is how we illustrate helium. Then, kahit na 2 lang yung kanyang shell, yung kanyang electrons, at 1 yung kanyang shell, it doesn't mean na helium is, hindi niya na-fulfill yung octet rule. Siya yung exemption kasi kahit 2 lang yung kanyang valence shell, or valence electron, na-fulfill pa rin ni neon yung kanyang yung octet rule. So, this is a stable element pa rin. So, let us have another example. We have here carbon. Carbon. So, si carbon, meron siyang 6 atomic number. So, meron siyang 6 electrons. So, let's draw this or illustrate this in a nuclear model. 1, 2, another shell, 3, 4, 5, 6. Okay, so 6 electrons present sa carbon. So, yung valence shell niya, ito. Valence shell. Okay? So, ito naman is the valence electron. So, na-fulfill ba ni carbon yung octet rule? Let's see. 1, 2, 3, 4. So, meron lamang siyang 4 electrons sa kanyang valence shell. So, ibig sabihin, hindi na satisfy ni carbon yung octet rule. Okay? So, kinakailangan na mag-gain pa siya ng another 4 electrons para magkaroon siya ng 8 valence electrons at ma-fulfill niya yung octet rule. So, elements like carbon here tends to lose, gain, or share electrons to reach a total of 8 valence electrons called an octet. So, this losing, gaining, and sharing of electrons to become stable and satisfy the octet rule is what we call the chemical bonding. Our lesson today, we will going to discuss 2 types of chemical bond. The first is the ionic bond and the second is the covalent bond. So when we say ionic bond, it is a bonding between metals and non-metals. So it is also called as the transfer of electrons since the electrons are transferred from one atom or element to another atom. So this is where metals loses electrons and non-metals accepts the electrons. So diba, we all know that electrons is a negative charge. So when metal loses electrons, it means that metals becomes more positive and non-metals that accept the electrons becomes more negative. Okay? So next naman is the covalent bond where it is the bonding between two non-metals. So it is the sharing of electrons. So walang naglo-lose at nag-gain ng electrons. Pero silang dalawa, yung two non-metals, they are sharing those electrons para maging para maging stable sila at ma-fulfill nila yung octet row. So let us have an example here. So now, let us identify the type of bond present in the following compounds. So first, we have NaCl, second CO2, third CaCl2, fourth CCl4, and fifth is AlCl3. So first, let us have our periodic table. So here, makikita natin yung guide or group of elements present in the periodic table. So, this is how to determine whether the element is metal or non-metal. So, makikita nyo siya dito sa side na to. Okay? So, first, let us have NaCl. So, yung una natin gagawin is to identify kung metal ba ang element na to, yung compound or non-metal. So, first, NaCl. So, si Na ba ay metal or non-metal? So, let's see. So, Na, according to the periodic table of element, is an alkali metal. So, Na is a metal. Sodium is a metal. Cl naman, it is in the group of halogens. Okay, so it means it is a non-metal. So, NaCl is a combination of metals and non-metals. This means it is a what type of bond? Very good, ionic bond. Bonding between metals and non-metals. Next is the CO2. So, si carbon ba, si C ba, ay metal or non-metal? C. Okay, so si carbon ay nasa category ng non-metal. Okay, how about si oxygen? Okay, oxygen is in the category of nonmetals as well. So it means this compound is a combination of both or two nonmetals. So this means the bond is very good. It is covalent bond. Okay, nagigets na ba, class? Yes, hindi siya mahirap, no? Next is Ca. So si calcium ba ay metal or non-metal? Calcium. Calcium is an alkaline earth metal. So it means it is a metal. And Cl again is, or chlorine, it is a halogen. So it is non-metal. So this CaCl2 is a combination of metals and non-metals. This means the type of bond is very good. It is ionic bond. Okay? Next, CCl4. CCl4. So, si carbon ba again? Metal or non-metal? Non-metal. So, CCl is halogens, which is non-metal as well. So, the combination is both or two non-metals. So, this bond is very good. It is covalent bond. Okay? Lastly, AlCl3. So, si Al ba or si aluminum ba, is it metal or non-metal? Okay, so si aluminum is a basic or poor metal. So, it means it is a metal. And si Cl, chlorine, is a halogen. So, it is non-metal. So, AlCl is a combination of metal and non-metal. So, this means it is an ionic bond. Okay, very good. So, nakuha na ba? Okay, madali lang siya. So, kailangan nyo lang ng periodic table of elements para ma-determine yung type of bond, whether it is ionic or covalent. Okay? So, we have learned that covalent bond is a shared pair of electrons between two atoms, which is nonmetals. But, are the electrons equally shared by the combined atoms? How does polar covalent bond differ from nonpolar covalent bond? And how does electronegativity of an atom helps in classifying covalent bond into polar and nonpolar? So these questions will be answered as we go along our discussion for today. Polarity of molecules are determined by two factors. First is the polarity of bonds and electronegativity, and the second is the polarity of molecules and molecular geometry. First, let us discuss about the polarity of bonds and electronegativity. Okay, so first, let us discuss what is electronegativity. So I have already introduced to you this topic right from the periodic trend. So one of those trend is the electronegativity. And again, electronegativity, it is the measure of the tendency of an atom to attract electron to itself. So it is how likely an atom attracts electron to itself. So what can you observe in this table? Very good. So electronegativity increases from left to right, and electronegativity decreases from top to bottom, right? Okay, so the higher the value of electronegativity, the more it tends to attract electron to itself, and the more it becomes negative. So here, these elements that has higher electronegativity, it means mas madali sa kanilang maka-attract ng electron. And when they attract electron, they become more negative, since electron is a negative charge. And these elements naman here that has a lower value of electronegativity, it means mas mahirap sa kanilang maka-attract ng electron. So they becomes more positive since they give away their electrons na lang. Okay? So, gets na? Yes. So, what is the connection of electronegativity to the polarity of bonds? Okay, so we could use the electronegativity values of the atoms involved to get the absolute electronegativity difference. So what is electronegativity difference? So electronegativity difference, it helps us in predicting what type of chemical bonds that would exist between the atoms. So when we say difference, it is the value after we subtract something, okay? So we can use this electronegativity difference to help us predict what type of chemical bond that would exist in the atoms, whether it is ionic bond, polar covalent bond, or nonpolar covalent bond. So here is the type of bond based on the electronegative difference of bonded atom. So if the electronegativity difference is more than or equal to 1.7, the type of bond will be ionic. And if the electronegativity difference ranges from 0.5 to 1.6, the type of bond will be polar covalent. And lastly, if the electronegativity difference is less than or equal to 0.4, the type of bond will be nonpolar covalent. Okay, so this is our guide to know whether the bonded atoms will be ionic, polar covalent, or non-polar covalent. It will be based on its electronegativity difference. Okay? So now let us have an example. We will now identify the polarity of molecules based on its electronegativity difference. So first we have calcium and chlorine. Second is two chlorine atoms. Third is hydrogen and chlorine. So first, let us have our electronegativity values here as a guide and the type of bond based on its electronegativity difference table. Okay, so first, let us know the electronegativity difference of an atom. So first, we have calcium. So calcium has an electronegativity value of 1.0. Okay, next naman is si Cl. Chlorine has an electronegativity value of 3.0. So, now, since meron na tayong electronegativity values, we must find the electronegativity difference. So, paano natin makikita yung electronegativity difference? We will just simply subtract this electronegativity value. So, 1.0 minus 3.0 is negative 2.0. So, i-disregard natin tong negative sign. So, it will be 2.0 na lang. So, 2.0 is more than 1.7, right? So, it means the type of bond will be ionic bond. Ionic bond. Okay? Let's check. Okay, so it is Ca and Cl is an ionic bond. Okay, so next we have two atom of chlorine. So chlorine again has an electronegativity value of 3.0. So two atoms, so dalawang 3.0 to. So isa-subtract mo lang siya to get the electronegativity difference and it will be 0. So 0 is less than 0.4. So this means two atoms of Cl is a non-polar covalent. So, nonpolar covalent bond. Okay, nagets na ba? Let's check. Okay, 3.0 minus 3.0 is 0 and it is a nonpolar covalent. Next, we have here hydrogen and chlorine. So, hydrogen has an electronegativity of 2.1. And chlorine again has an electronegativity of 3.0. So, to get the electronegativity difference again, we must subtract their electronegativity value. So, 2.1 minus 3.0 is negative 0.9. So, disregard the negative sign, it will be 0.9. 0.9 is under the polar covalent. Polar covalent. Okay, so polar covalent bond, yung type of bond ng HCl. So let's check. Okay, so polar covalent. So that is how we will identify the polarity of molecules based on its electronegativity difference. So nakuha na ba, class? Very good. So now let us discuss what is polar covalent and what is nonpolar covalent bond. Okay, so first let us discuss about polar covalent bond. So covalent bond, as we discussed a while ago, is a sharing of electrons between two non-metal atoms. But in this case, polar covalent is an equal sharing of electrons, meaning hindi pantay yung sharing of electrons between the two atoms. Okay? And then the bond pair of atom form an electric dipole. So, dipole means two poles, so dalawang poles, which means that one molecule has a positive end or a positive pole and the other end has a negative pole. So, this is how we illustrate electric dipole. Okay, an atom with high electronegativity value becomes partially negative pole. So this is how we illustrate the negative pole, sigma negative, okay? And then an atom with low electronegativity value becomes partially positive pole. So this is how we illustrate positive pole, sigma positive, okay? So the direction of the arrow is always pointing into the more electronegative pole. So yung direction daw ng arrow na ito is pointing to the more negative pole. So sino yung mas negative? Sino yung mas high yung electronegativity? Doon magpo-point yung arrow. So for example, we have here hydrogen and chlorine. So hydrogen has an electronegativity value of 2.1, right? And then chlorine has an electronegativity value of 3.0. So sa kanilang dalawa, sino yung may mas malaking electronegativity value? Si chlorine. So si chlorine yung mas malaki yung electronegativity value. So, siya yung negative pole. So, ito yung kanyang sign or symbol. And then, si hydrogen naman, siya yung may low electronegativity value. So, siya yung positive pole. So, ito siya. And then, as you can see in the arrow, yung direction ng arrow is towards kay Cl. Since siya yung more electronegative pole. Okay, gets na ba? Next, another example, we have here hydrogen and fluorine. So, hydrogen has electronegativity value of 2.1 and si Fluorine naman has an electronegativity value of 4.0. So, sa kanilang dalawa, yung may high electronegativity value at yung may negative pole is si fluorine. And then, yung low electronegativity value and may positive pole ay si hydrogen. So, the arrow is towards fluorine. Okay? Gets na ba? So, that is the polar covalent bond. So now, let us have non-polar covalent. So kanina, polar covalent is unequal sharing of electrons. So hindi pantay yung sharing of electrons on polar covalent. Now, in non-polar covalent, it is where equal sharing of electron pair happens. So, bonding atoms have approximately equal electronegativity value. So, for example, we have here hydrogen, chlorine, oxygen, and nitrogen. So, H2, so a combination or a bonding between two hydrogen atom is an example of non-polar covalent. So, hydrogen has, two hydrogen atom has equal electronegativity value. Chlorine 2, so 2 chlorine atom has an equal electronegativity value. O2 or oxygen 2, so two atoms of oxygen has the same or equal electronegativity value, and so as to nitrogen 2, which has also same or equal electronegativity value. So that is the nonpolar covalent bond. So now we are done with the polarity of molecules and electronegativity. So yung category na yun is applicable lang sa mga dalawang atoms only. But for polyatomic molecules or those molecules consisting of two or more atoms, polarity of molecules and molecular geometry will help us determine the overall polarity of the molecules. So now let us proceed to the steps on predicting the shape or molecular geometry of a substance. So first step is to determine the central atom of a molecule or the center atom ng molecule. So the central atom is the least electronegative element. So kung sino yung may pinakamaliit na electronegativity value, yun yung magiging center atom. So let us have an example. So we have here H2O, water molecule. So first, what we will do is to get their electronegativity value. So yung electronegativity value ng hydrogen is 2.1. But since meron tayong dalawang atom or element ng hydrogen, this will be another 2.1. So we will add that. 2.1 plus 2.1 will be 4.2. So 4.2 will be the electronegativity value of H2. Next naman is we will get the electronegativity value of oxygen. So oxygen has an electronegativity value of 3.5. Okay? So nandito yan sa periodic table of elements ninyo. Okay? So 3.5 yung electronegativity value ng oxygen. So sabi dito, the central atom is the least electronegative element. So, sino sa kanila yung may pinakamaliit na electronegativity value? Very good. It is the oxygen. So, meaning, oxygen will be our central atom. Okay, let's erase this one. Okay. So, oxygen center and then hydrogen on the side. Okay? Next step is to draw the appropriate Lewis dot structure for the molecule. So, paano natin i-draw yung Lewis dot structure? So, first, let us know, dapat natin makita or mahanap yung valence electron, to know their valence electron. So, first, let us have oxygen. So, oxygen has an atomic number of 8. So, we will just illustrate it first in a nuclear model. So, oxygen, 1, 2, 3, 4, 5, 6, 7, 8. So, meron siyang 8 electrons. Okay? So, we will get their valence electron. Nasaan ba yung valence electron? Nandito sa valence shell niya. Okay, let us count the valence electron. 1, 2, 3, 4, 5, 6. So, this means 6 yung valence electrons ng oxygen. So, the dot will be 6 as well. So, 1, 2, 3, 4, 5, 6. So, this is the Lewis dot structure for oxygen. Okay, na-gets na? So, yung Lewis dot structure is depende sa valence electron ng element. Okay? Next is hydrogen. So, si hydrogen is may atomic number na 1. So, isa lang yung shell niya. Ito yung magiging valence shell niya. And then, the electron will be 1. So, that is the nuclear model for hydrogen. And the Lewis structure or Lewis dot structure of hydrogen will be this one. 1 dot only. Okay? Okay. Next is step 3. Count the number of bonding pairs of electrons and non-bonding or lone pairs around the central atom. Okay, so bonding pairs. So itong electron ni oxygen na walang pares is ibabond or i-connect natin siya dito sa electron ng hydrogen. And then this one as well. So, magiging stable. So, nag-share na sila niyan ng kanilang electrons. Okay? So, this one is what we call the bonding pairs. Okay? And this one na walang kapares is what we call the lone pairs. So, lone pairs, these are the bonding pairs that bonds to the other element. So, since ito hindi naman nakaband sa other element, hindi siya nakaband sa hydrogen. So, this means itong dalawang to is lone pairs or are lone pairs. Okay? So, next naman is to determine the electron pair orientation using the total number of electron pairs. Okay, so meron siyang dalawang electron pair. Next naman is name the shape of the molecule based on the location of the atoms. So here is an example. So these are the different molecular shapes, okay? So based on our molecule, the H2O, since meron lang siya ditong one bonding pairs and the other side is one bonding pairs, it is a resemblance of the bent or angular shape, okay? So, ito yung bonding pairs at ito yung lone pairs, okay? So, our H2O here is bent or angular shape, okay? Bent or angular shape. So, that is how we determine the molecular shape of a molecule. Gets na ba, class? So let us have here an example. So first we have predict the molecular geometry of BCl3. So boron and chlorine 3. So boron and Cl3. Okay. So first, let us determine their electronegativity value. So boron has an electronegativity value of 2.0. Okay. And chlorine has an electronegativity value of 3.0. Since tatlo yung chlorine, tatlong 3.0 dapat yung nandito. Okay. Then add this 3699.0. So, sa kanilang dalawa, sino yung may mas maliit na electronegativity value? So, si boron. So, this means boron will be our central atom. Okay? Central atom will be boron. Okay, now let us have their Lewis dot structure. So first, si boron, hanapin muna, let us know first their valence electron. So si boron, meron siyang atomic number na 5. 1, 2, 3, 4, 5. So this means meron siyang 3 valence electron. Okay? So, ibig sabihin, 3 yung dots niya. 1, 2, 3. Okay. Si chlorine naman, meron siyang atomic number na 17. Cl. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, 8 na yan. Let's proceed to another shell. 10, 11, 12, 13, 14, 15, 16, 17. So, ito yung valence shell niya. Valence shell. So, inside that valence shell, yung valence electron naman naka-attach doon. So, let us count the valence electron. 1, 2, 3, 4, 5, 6, 7. So, si chlorine, meron siyang 7 valence electron. Okay? So, ibig sabihin, merong 7 dots si chlorine. Okay, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. So now let us bond this together. So let us bond this one, this, and this. So they are now sharing their electrons. So let us count the paired electrons. Yes, let us count their paired electrons. So 1, 2, 3. Okay, so the shape is triangular planar. So this means the molecular geometry of BCl3 is triangular or trigonal planar. Kasi para siyang naka-triangle, right? Okay, so let's check. Okay, very good. So the molecular geometry of BCl3 is trigonal planar. Okay, next. Let us predict the molecular geometry of CO2. Okay, CO2. So first, we must find their electronegativity value. Okay, so si carbon, meron siyang electronegativity value na 2.5. Meanwhile, si oxygen, meron siyang electronegativity value na 3.5. 3.5. Pero dalawang oxygen yung nandito, so another 3.5. Add this 0, 1, 6, 7. Okay, so 7.0. So, sino sa kanila yung may least electronegativity value? Si carbon. Okay, so si carbon yung magiging central atom natin. Okay? Carbon will be our central atom. So, carbon here, oxygen, oxygen. Okay, now Lewis dot structure. Okay, so what is the valence electron, or how many valence electron are there in carbon? So carbon has 6 electrons. 1, 2, 3, 4, 5, 6. So si carbon meron siyang 1, 2, 3, 4. 4 na valence electron. This means 4 dots. Okay, 4 dots. 1, 2, 3, 4. Okay. So si oxygen meron siyang 8 electrons. Oxygen, 1, 2, 3, 4, 5, 6, 7, 8. So, yung valence electron ni oxygen, 1, 2, 3, 4, 5, 6. Okay, so meron siyang 6 valence electron. This means 6 dots, yung Lewis dot structure niya. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then, let us now have, okay, so let's change the structure here. And then here. Okay, now let's connect the dots. Okay, or let's bond them together. Bond, 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 and bond. So, okay, so there are 1, 2, 3, 4. 4 electron pair bond, or 4 electron bond pair. And then the shape or the geometric or molecular geometry is linear. So, nakalinya lang siya. So, it is linear. Okay? Kasi pag isa lang yan, yung nandyan, kung isa lang yung electron bond pair or bond pair, magiging bent yan. So, ito naman, meron siyang dalawa, so magiging linear. Okay? So, linear yung kanyang molecular geometry. Let's check. Okay, linear. Next, we have CHCl3. Okay, CHCl3. CHCl3. Okay. So, tingnan muna natin kung sino yung may least electronegativity value. So, si carbon, meron siyang 2.5 electronegativity value. Hydrogen, meron siyang 2.1. And then si Cl, meron siyang 3.0. Tatlong Cl, so tatlong 3.0. Okay? 369.0. So, sino sa kanila yung may pinakamaliit na electronegativity value? Okay, si hydrogen. So, si hydrogen yung central atom natin. Okay? Hydrogen, central atom. Okay. Okay, but hindi pala si hydrogen yung magiging central atom natin. Kasi si hydrogen is normally a terminal atom. So this means carbon, again, 2.1, 2.5, 9.0. So, hindi si hydrogen yung magiging central atom natin kasi terminal atom siya since meron lang siyang 1 electron. So, this will leave us to carbon. So, si carbon yung magiging central atom natin. Central atom, carbon. Okay, Cl3 and then si hydrogen. Okay, now let us find their Lewis dot structure. So si carbon, meron siyang atomic number na 6. 1, 2, 3, 4, 5, 6. So meron siyang 4 valence electrons. So 4 dots. 1, 2, 3, 4. Okay, now si hydrogen meron siyang 1 electron. So yun yung magiging valence electron niya. Okay? So hydrogen. Okay. Now let us have chlorine which meron siyang valence electron na 7. Okay? 1, 2, 3, 4, 5, 6, and 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now let us bond this together. Okay, bond, 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 bond. So meron siyang 4 na bond pairs. Okay, so the molecular geometry of CHCl3 is tetrahedral. Okay, so tetrahedral. Since meron siyang 4 na bond pairs. So let's check tetrahedral. So that is how we predict the molecular geometry of molecules. Gets na ba, class? Very good. So here we have the flow chart to determine if a molecule is polar or non-polar. So after determining the geometrical or molecular geometry of the molecule, let us now determine whether the molecule is polar or non-polar. So first is, so we have here the examples. BCl3, CO2, and the CHCl3. Okay, so first, BCl3. Is the shape symmetrical in 3D? Yes, it is trigonal planar. Next, so dito tayo sa yes. Okay, are all atoms bonded to the central atoms the same? Same ba yung bond ng mga elements sa central atom? Yes, it is the same. Okay, so this means the molecule is non-polar. Okay, non-polar. Okay, next. CO2. Is the shape symmetrical in 3D? Yes, it is symmetrical. It is linear. Okay, yes. Are all atoms bonded to the central atoms the same? Same ba? So, dalawang bonded pairs. So, same siya. Bonded in the central atoms. Okay. It is non-polar. Okay. Lastly, CHCl3. So, is the shape symmetrical in 3D? Yes, it is tetrahedral. Are all atoms bonded to the central atoms the same? All atoms ba bonded sa central atom? Let's see. So, si hydrogen bonded. Si Cl3 bonded naman. Pero, are they the same element? No, because tatlong Cl3 at isa lang yung H. So, this means it is a polar molecule. So, dapat kasi lahat ng bonded na atom sa central atom will be same elements lang. Ngayon, merong nahalong hydrogen na bonded sa central atom. So, this means hindi the same yung atoms na bonded sa central atom. So, it is polar molecule. So, let's check. So, let's check if our answers are correct. So, number 1, BCl3, nonpolar. Okay, nonpolar. Next, CO2, nonpolar. Okay, very good. It is nonpolar. Next is CHCl3. Polar or nonpolar? It is polar. Very good. It is correct. So that is how we determine whether the molecules are polar or nonpolar. So now let us identify if the following is polar or non-polar. First, we have NH3. So NH3, ito yung kanyang Lewis structure. And ito yung kanyang molecular geometry. So same ba or symmetrical ba yung Lewis structure at yung molecular geometry niya? Yes, it is the same. And the question, another question, are all atoms bonded to the central atoms the same? So lahat ba ng atoms or ng electrons ng central atoms bonded ba? Hindi. So, meron pang lacking dito. So, hindi equal yung distribution ng electrons. So, this means NH3 is a polar molecule. Okay. Next, we have H2O. So, ito yung Lewis structure ng H2O. Dapat wala na tong electrons dito kasi isa lang naman yung electron ng hydrogen. So, this is the Lewis structure and this is the molecular geometry. So, the same ba yung Lewis structure and molecular geometry ng H2O? Yes, it is the same. Are all the atoms bonded to the central atoms the same? So, lahat ba ng electrons ng central atom are bonded? Same ba yung bonding? So, hindi lahat ng electrons ng central atom are bonded. So, meron pa natitira dito. So, hindi equal yung distribution ng electrons. So, this means H2O is a polar molecule. Okay? Next, we have CCl4. So, ito yung kanyang Lewis structure. Ito yung kanyang molecular geometry. So, the same ba? Symmetrical ba? Yes, it is symmetrical. Are all atoms bonded to the central atoms the same? Same ba yung bonding ng atom sa central atom? Nung other atom sa central atom? Yes, it is the same. So, it means equal yung distribution ng electrons. So, this means that Cl4 is a non-polar molecule. Okay. Next, lastly, we have HBr. So, this is not a polyatomic molecule kasi dalawa lang. Okay? So, we have here H and Br. So, ito yung kanyang Lewis structure. Molecular structure niya is ganito. So, the same ba? Yes, it is the same. But, the distribution of electrons are or the sharing of electrons are unequal. So, hindi pantay yung sharing of electrons. So, mas maraming electrons si bromine kaysa kay hydrogen. So, this means Ito ay ito ay polar. Okay? This is polar. Okay? So that is how we identify whether the following or the molecule is polar or non-polar. I hope that you have learned a lot from this lesson, polarity of molecules. Thank you. Thank you for watching, Science-Minded Learners. Until next fun-filled science adventure. Bye!